Okay, so Virtual PLC, what's that? So CODESYS Virtual Control SL, that's the official name of our PLC product. It's basically just the same old CODESYS control runtime that we've had for many platforms such as Windows and Linux for years now. It's the same performance, it costs the same, it uses the same licenses, and it offers the same features. It's just put in a container. So that raises the question, what's a container? Well, it's a shipping box on boats, but that's a different kind of container. For us, it's oversimplified, it's just a very lightweight virtual machine. So the difference to a virtual machine, though, is that it uses the host kernel and network stack. Still has its own file system, including all the system libraries. It offers very nice and easy ways to get UDP and TCP networking set up. And it's overall really easy to set up networking and file sharing between a Docker container or a Podman container and the host. Much easier than with a VM. They can also very easily be replicated. So they're delivered to you as an image, which is the whole container already ready-made. And then you instantiate them, and then they become a container instance. You can make a new container from an image in seconds. You just type in the command, and then it'll appear. And you can also delete a container within seconds. So that's a big difference to a VM, because anybody who's ever set up a VM knows that it kind of takes a while to set them up. And even if you just copy an existing one, they're very large. So just copying them takes a minute. And then when you start them, the full OS needs to start. So that also takes a while. Looking at the pictures on the right here a little bit, we can see that both containers and VMs, they still have a hardware. They still have an operating system on the host. But then you have the VM host for the virtual machine side, which follows by individual VMs that each have their own guest OS and then the application you want to run. Containers, on the other hand, you just have the container host and then directly the container on top. So there is much less OSs involved if you have containers. And that's kind of why they're lightweight. So deleting the guest OS is really where containers shine. So for our container-based runtime, to get that set up, well, first we have our hardware, the host OS and all that, and then the container host. But the first thing we need to do is put the images for the containers we want to instantiate into the host. So we can put those in there. Then next, we instantiate the containers from those images. Then we can configure the file system access. So my runtime container, for example, it'll have access to a folder on the host to permanently store the information, because containers in their nature are very transitive. And so their file systems, if you store stuff in there, there's a high chance it gets lost. And we don't want that with our controller data and config. So we store them in a host directory that's permanent. Next, we set up the communication. So Docker has an internal network that connects containers to each other. For example, we have a runtime container and a container containing the CODESYS gateway that allows access to this internal subnet through the CODESYS IDE. Those get automatically added to that network, and it automatically has access to the outside world. And we're gonna also map one specific port, this port 1217, from the gateway container to be reachable from the outside on port 1217 on the host. So anytime I now talk to the host IP address on port 1217, those messages automatically get forwarded to the gateway container. Oh yeah, now my images come up. And lastly, we need to set up a NIC for the real-time buses, because by default, Docker isn't really good with real-time Ethernet buses. It only knows UDP and TCP, but real-time buses like EtherCAT and Profinet, they use raw Ethernet frames for the high-speed, high-reliability data, and those aren't supported, so we need to physically take one of the NICs from the host and give the container full control over it. So all of that is full standard Docker, right? Well, not fully. Like I said, Docker doesn't do the raw Ethernet for EtherCAT and Profinet. So that last step I mentioned, where we take a host NIC and assign it to the container, that requires some additional commands to be run. And our VPLC comes with tools that make running these commands easy, or they actually run it for you. Yeah, so without further ado, let's take a look at a quick demo, and let me see real quick if I can get my camera set up so you can see stuff. Okay. I think it's double backgrounding. So do you see my slideshow now in the camera too?
No, not yet.
Oh, okay. All right, well, let's open up the CODESYS IDE. And now the first thing that we'll need to do is add the support for the Virtual PLC to my CODESYS IDE installation. So for that, we go to Tools, and then the CODESYS installer. And then that'll open up. Yeah, and so now we have the CODESYS installer, which allows us to put additional add-ons in the installation. So for the virtual control, switch over to the Browse tab, because that'll be new. I search for Virtual Control SL, I select it, and then I can hit the Install button to install it. To save a little bit of time, I've already done that. So I'm not gonna press that again right now. Now, once we have that, we can do the steps that I showed you on the slideshow, so we can deploy the images. For that, we can open the deployment GUI, which is under Tools, and then Deploy Control SL. And here we see all the information to connect to our target. So in this case, I've set up an IPC. I can type in its IP address. Then I add a user and password. And then this tool will use SSH to connect to the target and then run all the commands we need. So now that we're talking to the target, let's put the images on. So here I have the image deployment screen, and I can select the virtual Linux image. I can install that. And that now gets transferred to the controller. And there we go. And now we can do the same with the edge gateway. And now we have that. Right. So now we have the images available. Let's make some container instances. So the first one we want, we'll call it GW for gateway, and it'll use the edge gateway image. And the next one we'll want is a runtime image, and I'll just call that runtime. Right. So now for these images, we can provide some configurations. So the one is auto start. So do I want this to come up automatically when the IPC starts? In this case, I don't want that because this is just for this demo today. But I could set that to true, and then it'll automatically start every time the controller starts. And then I see a few other settings here, but the one most relevant for the gateway is this port setting. So this is where we're saying that port 1217 on the host should be mapped to 1217 in the container. So that's all automatically populated, and that's what we want. So we got that. And now let's look at the runtime configuration. So here we see similar settings. It just, this capabilities one is clearly very filled. So these capabilities basically give this container additional permissions to do things that Linux by default doesn't allow containers to do. And those are needed to run it with good real-time behavior and do all the networking things we need to run field buses like EtherCAT and Profinet. Okay. Yeah, there's a few more settings, and we'll cover a few of them later, but the one that's relevant for us right now is the NIC setting. So this is where we could do the mapping from an Ethernet port on the host into the container, so we can use it for EtherCAT. So to find out what Ethernet adapters we have on the host, let's SSH into our controller. And I've put my SSH keys on it. It automatically logs in without a password. And then we can run the command IP --A, and that'll show us all the network interfaces that exist. At the top of the list, we have the loopback adapter. So we're going to ignore that. So that's not, it's only talking to ourselves. Then we have ENP1SO and 2SO and ENO1. Those are the physical adapters, and then we have the virtual Docker one. We can see that ENP1SO actually has the IP address we're using to talk to the device. So we can ignore that one as well. And then ENP2SO and ENO1, those are available for our fieldless use. And in this case, I've set up EtherCAT on the ENP2SO port. So we're going to map that. So all we need to do for that is just type it in here, and then our tools will take care of making this NIC available inside the container. Sorry. Here. And now we have them. And now we can go to the status and command tab, and we can start all our containers. And now we're telling these Docker containers to be started up and the network ports mapped. So next, let's make a little example project. So we just make standard new project. Just call it untitled, a favorite name for a project. And then as the target platform, we select our virtual control for Linux SL. Then I'll choose Ladder as the implementation language for today. So now we're making the new project, and now we can see our project. So let's set up the communication to the controller. So for that to work, we need to be able to talk to the gateway. If I do a network scan right now, this just scans our office, and I'm not going to find the containers or the container that I just instantiated because it's in a segregated virtual network from the Docker. So the way we get access to that network is through the CODESYS gateway. The default gateway 1 is actually the gateway running on my local laptop, but I want to use that gateway container I created instead. So I will add a new gateway, and then I'll call that the container. And then I can give it the IP address, and I'm just typing in the IP address of the Docker host that I have, because I mapped this port 1217 on it to connect into the Docker container. Say OK here. And now I can select that gateway, and it comes up green, so we're talking to it. And if I do a network scan now, that scan happens in the Docker internal network only. And I find only containers that are in this internal network. And you can see here I have the runtime. And I can just select that. And now it obviously wants me to create user management. I'm going to do that real quick. And now I can log in with my new user. And there we go. This is our runtime. Current version. all looking good. So let's add the field bus. So this works just like it works with any other controller. We say add device. Go find the dialog that popped up. And then under field bus is an EtherCAT. We add the EtherCAT master. Now I have my EtherCAT master. I can use the normal button that I use to scan for the Ethernet devices. And ETH0, that's the connection to the virtual Docker network. We don't want to use that. And EMP2SO, that's the NIC from the host that we just mapped into the container earlier. So we're going to select that. And now what I'm going to do is I'm going to just quickly log in and download the application. What this will do, it'll download the EtherCAT stack to the controller. And then if I log out again, Zoom controls don't hide it, I can now right-click this master and I say scan for devices. And this will use the EtherCAT network scan functionality, and it shows me all the modules I've connected. So in this case, it's an EK1100 field bus coupler, and then the digital input and a digital output device. So I'm just going to copy all of them to my project. And no, I did it wrong. I think I shouldn't have clicked it. There we go. Okay. And now we can map our I/O channels. So this first one is the input, and I have a button wired up to the first one. So I'll wire up that button, or make a global variable called button for that. And then on the outputs, I have a little traffic light of LEDs. So I'm going to say red, yellow, and green. Okay, so now I can make my application, but I've cheated a little and prepared one, so you don't need to watch me code in ladder. It's not really my most fluent language. So I've just put my existing code in here, and it just uses like 2 blink function blocks. First one on the red light is only active when I press the button. The second one, the yellow, blinks always, and the green light is just straight output from the button. This uses the blink block from the util library. So I'm going to add that real quick. You say add library, and kind of a pro tip from me, if you want to find a library, instead of just typing it into the big search, you can also just switch to the list view, and then you get all libraries as a flat list, and then just type it, and it jumps to an entry that starts with the letters you just typed. So in this case, the util library. I'm going to add that in. And now I can download my application. Yeah, and now we can run that. And notably, you'll see that the EtherCAT master is reporting an orange circle. That means it's running, but it's unlicensed, so it's running in demo mode. And that's something we'll fix in a little. Yeah, if I stop my screen share, you see my camera better now? Or you should
Yes.
see.
Yes.
Yeah, there we go. And then, so I set up this I/O. You can see the EK1100 with the I/O devices, and if I hold the button, then the green light comes on and the orange blinks. And that is all done with our runtime running in a container right now. So that was that first demo. Now, let's continue. So next up, I mentioned that orange circle. That was because we don't have a license. So how do I license these virtual controllers? So the licenses themselves.
That is a camera of your application.
Oh, right.
Thanks.
Can move my picture. Yeah. Move my picture around, make it small. Yeah, so the licenses themselves are the same licenses used for all other controllers. So they're the application-based licenses, and you can buy them at us.store.codesys.com. You can see them all here, and if you click this link, you get to a nice overview page that shows you all the available licenses. Come on, picture. Okay. Oh, that's unfortunate. Normally there's a very nice picture here explaining it. Sorry you can't show you that. It's the office network being broken again. But you can see which licenses we have and what is needed from them. Yeah, so you can buy them on the store, and then the question is, how do you make them available to this runtime? So you could, the VPLC still uses the Weibo CodeMeter technology that we use for all other licensing of our store runtimes as well. The only difference is that you can't directly connect the soft container or USB dongle to it. That's because the soft container kind of works in the file system, and the Docker container file system, like I said, is very transitive, and it also relies on hardware identifiers to bind that container to the hardware, and Docker kind of removes all of them. So soft containers inside of Docker don't work. Similarly, Docker doesn't really like mapping USB devices into a container, so you can't do that either. So the solution is network licensing. So we're going to have a network license server that runs on a different machine, and then it connects to our container over the network. On the license server, we also run CodeMeter. It's the exact same software that we've always used, just with like 2 or 3 different settings. And this instance then talks to another instance of CodeMeter that runs inside the container. So the licensing flow will go that the CODESYS runtime asks the container CodeMeter for a license, and that container CodeMeter then in turn asks the network server, and that network server then goes to its local license storage, which is the classic soft container or USB dongle, because this is now natively running on a normal Linux machine. And it then provides the license and provides it back to the CODESYS runtime. And this all sounds a little complicated, but we've made it like easy to set up, and you can do it with a few clicks. And that's what we're going to do in our next little demo here. So you're going back to my CODESYS project. I'm going to log out, and then to set up a license server, we again go to the CODESYS installer, and we kind of put the license server feature into our IDE. So again, I search for a license here, and then I get the CODESYS license server for Linux SL, and I can install that into my IDE, which again, I've already done. And since I've already done that, I can go to update license server and pop up the UI, manage my license server here. So I'll add my SSH user and password again. I type in the IP address. And now if I hit the install button, it's again going to use SSH to connect and install our license server and a little UI for that. Right. So you can see here in the message view all the things it's done, and it's already finished. And our license server UI isn't actually a standalone UI. It uses a tool called Cockpit, which is a standard web management UI for Linux. So since I just installed that, I need to trust the self-signed certificate. But now that I'm connected, I can just use my normal Linux user and password to log into Cockpit. And in here you see like a lot of standard screens to manage the system. But you also find a CODESYS web-based, CODESYS WBM, which stands for web-based management. And here I can log in. And at the bottom, I can find all the You have a printout that shows me all the containers that exist. It looks like I accidentally stopped code meter. Let me get that restarted. I'm gonna refresh here. I actually see the excuse me, the list of all the containers that exist and their serial numbers. So in this case, it's an empty license container, so we see very little here. But if you look at one that has licenses, you would see a very long list. So if I want to install a license, I can use these fields up here. So the firm code, you just leave as is. And then the serial number, you put the serial number of the container you want to install it into. So in this case, it would be the soft container here that was automatically created. And then the ticket number is what you get from the CODESYS store when you buy the license. It gets sent to you by email, but you can also look at them in your store account. So you would type that in here and then click activate license. Then it does some thinking. And then once it's done, you can refresh this list and you would see your licenses show up in the printout down here. That's how you activate a license. I'm not going to do that for today because we already have a very nicely stocked license server in our office, and I'm going to use that. So let's connect our runtime instance to our license server. So for that, I go back to my deployment screen, and I'm going to have to change the configuration of the runtime. So I need to stop that container. So I'm going to do that real quick. And now I can go back to the configuration screen and edit my runtime configuration. So now I'm going to use this license server entry here, and I'm going to type in the IP of my license server. In this case, it's on .199 on our local subnet. And I say OK. And now I start the runtime. Now if I log back in, then we'll notice that the circle is now green, so it has a license. Go to the status page, it just says running. Before that, it would have said running in demo mode. And then if I go to the PLC log, I can see that during startup, it also somewhere says runtime license. There. If it wasn't licensed, it would say that it's not licensed and that it's running in its 2-hour demo mode. And that is how easy you can license our virtual controllers. So with that, let's get back to the PowerPoint. And look at that. Right, so this was all pretty neat, but many applications, especially the ones that use motion and things, they have some functional safety aspect to it. So you still need a yellow safety PLC, which is kind of a bummer because everything else is virtual. Well, fortunately, we do have a solution for that as well, and it's our new Virtual Safe Control SL product. We're going to bring on the market later this year. And it actually does the dual channel execution that you need for SIL3 safety, but without special hardware. It uses a patent coded processing technology from another German company called Silistra. And once our product is, well, the product we have is already done. It's currently in the process of being certified by TVZUD under IC 61508 for SIL3. The safety runtime works in conjunction with our regular runtime. So the regular runtime does all the normal application stuff and takes care of running the field bus. And then the safety runtime kind of attaches onto the normal runtime and does the safety logic. With the initial release, we'll support ProfiSafe host version 2.6. So it'll be a ProfiSafe release. And then FSOE, so failsafe over EtherCAT, will come up in one of the following releases. It's already done. We just looked at the amount of paperwork needed to certify it and decided to start with one release and then get on the paperwork for the second. It's really quite the paperwork exercise. So how does this coded processing and also the diversified encoding it uses, how does this work? How do we get dual channel on non-safe hardware? So we have our safety inputs that are provided by the safe IO. And then we have our safety function blocks. So we run them twice. So we run them once, like natively, kind of as they're coded. And then we run them a second time in an encoded fashion. So the way this encoding works is I have a simple example. So one example could be you multiply every number in your math by 10. So whereas the unencoded version is 1 + 1 = 2. So that would turn into 10 + 10 = 20. And then you can check in the end, yeah, 20 is 10 times 2, so both channels get the same result. Now let's assume our adder unit in our CPU is broken for whatever reason. And then 1 + 1 = 3 all of a sudden. Now if we do that same math in the encoded, we get 10 + 10 is 21. Well, 21 doesn't even divide by 10, and it's also not 3 times 10. So we know we're now in an unsafe state. And that's kind of how you can do it without special hardware. This diversified encoding, people, very smart people have done the math on it and is like 99.99999% guaranteed to have a different result if there's a hardware failure than the native execution, thus giving you the high certainty that SIL3 requires that you can detect failures. And curiously, we actually run both of these in the same thread on the same CPU core back to back because the native execution is so fast. If you would multi-thread it, that overhead would take longer than just running it in the first place. Yeah, that's the basic of the diversified encoding. And then once you've run it twice, you compare the results. And you then have your safe outputs that are sent to the safe output IO, or you get into an error state, in which case the outputs would go into the safe state. Yeah, that's like kind of the 30,000-foot view on how it works under the hood. Now the technical requirements for you. So currently we only support Intel or AMD x86 CPUs. So it's your normal i3, i7, Ryzen. They all work. The only limit on them is they can't be faster than 15 gigahertz. I personally haven't seen any chip that violates that rule. So if you find one, let me know. I'll buy it for my gaming computer. It's mostly a theoretical limit because you got to do the math with something. And then the other requirement is you need a second clock source. And that second clock source has the background that there's safety timeouts. So if you haven't gotten a message within 100 milliseconds, for example, you go into safe state. And if the clock in your main computer would stop ticking, you wouldn't notice that 100 milliseconds have passed. So you need a second clock that can provide you a tick when time has passed. That. These are kind of the safety background or the technical requirements. And you obviously still need safety IO. So this technology only replaces the safety controller. It does not replace the IO. That is still yellow. And yeah. Yeah, now putting this a little bit into a picture. So on the left here, we have the aforementioned safety IO. In this case, it's a ProfiSafe IO that White Miller provided me for this demo very graciously. And this ProfiSafe IO is connected to a regular runtime that acts as the field bus master. This is a regular CODESYS control runtime. We'll actually be using the same one we just created in the previous demo for this. This runtime then talks to our safety runtime running in its own container through a shared memory. So the field bus master gets all the Profinet data, including the ProfiSafe data, and then takes the ProfiSafe data and puts it into the shared memory where the safety app is going to process it. And then externally, on the top right here, we have this time provider I mentioned running on a different device. And this time provider sends regular tick pulses via UDP on port 60,000, and the safety runtime is listening for that. So that's how the safety runtime can make sure that its own clock is still ticking and time is passing as it is expected to. Yeah, that's kind of the setup. So, picture is already better than words, but I personally believe that a demo is even better than that. So I am gonna demonstrate this all to you. It kind of follows very similar steps. You install the add-on into the CODESYS IDE. You then set up the images, you configure them, and then we can run an application. All right, so I'm gonna skip the CODESYS installer this time because I think you've seen it enough. But you would add that virtual safe control package the same way once it is released later this year. So then we go back to our deployment screen here. And now we can deploy the images that are relevant for the safe control. So I'm going to provide at the safe control image here. And then just to show you how it would be configured, I'm also adding a safe time provider, even though we're not going to run one on this machine, because it obviously needs to be on a different machine. Okay, so now I've added my images, and I can create 2 new instances. So I'm going to call this one safety, and it is safe control, pre-release build. And then we're going to just also add this one, and I'll call it time, so we can see how the time provider will be configured. So on the safety runtime, we can go into it. We again have very similar option. Just here we have dependencies, so we can say, okay, the safety runtime requires the normal runtime to be running, so I can add that as a dependency, making sure that the runtime is always running when the safety container starts. And then I need to tell it that it can access a shared memory made by the runtime. So in this IPC field, I type in container and then the name of the container I want to talk to. So I say a runtime. It's going to warn me quickly that we haven't told the runtime to share its data yet. We'll do that in a second. Next, we have the license server. This one we're actually going to leave blank because all the licensing is handled by the regular runtime. The safety runtime doesn't do that directly. Network and NIC we also leave blank. And network would be the Docker internal network if we want to connect it to any additional. And then NIC would be a network port, and we don't need that either because again, the regular runtime does all the field bus communication. Lastly, we have ports, and here we're adding a mapping from UDP port 60,000 on the host into the container, and that will be used to provide the safety time from the time provider. So say okay here. And then if we take a quick look at the time provider, that one I run on a different machine. And on that machine, I've changed the target IP to be that of this IPC I'm using. And the target port is that port 60,000 we just mapped into the safety runtime. So this I already have running on another IPC here in the office. Okay, right. Lastly, we gotta change the configuration on the regular runtime a little bit. And to that, I gotta stop it again. stop, and I can go edit its configuration. And the first setting we need to change is again the IPC settings. And we gotta say it's shareable. And then we're also gonna add a NIC to it, and then because we're running Profinet in addition to EtherCAT now. So we say ENO1, and then I can say a slash, because Profinet, unlike EtherCAT, uses IP addresses. So I need to give this NIC an IP address now. And just do 10.55.55.1. And I need to say what subnet we're on, and it's just /24 subnet. And now this NIC will also be mapped in and automatically assigned this IP address and subnet. Let's say OK. And now we can start this all up. Start the safe runtime and the normal run. Okay, beautiful. Now we have those running. So let's add the safety controller to our project. So to do that, we just right-click the top-level PLC, and then again say Add Device. And under PLCs, we're actually now going to find the safe controller. So we can add that in, and it'll be added as a child device to the controller, because it is kind of attached to it. If not physically, it's logically attached. And now let's add the nodes we need for the Profinet network. So again, we say add device. We want Ethernet IP adapter. Now, another tip from me, you can actually leave this dialog open and just select the next node, and it'll automatically update for what you can add under that node. I'm going to add a Profinet controller. Now, close that. And we configure this. Now, I gotta reconnect to my runtime. Let me restart the runtime real quick. Just stopping one instance at a time. Now let's select them again. And let's start them back up. There we go. Now we can talk to it again. But fortunately, turning it off and on again worked again. Best trick ever. All right, so now we can browse. Let me start CODESYS. Maybe that's the half that needs restarting. Apologies for that. I swear it worked every time I practice. We all know how live demos tend to work. New CODESYS. Reopen Untitled 1. Project backup. Now let's scan and log in. Hopefully. Yeah, there we go. Now we can see our Ethernet connection here. I want ENO1 for Profinet. Say OK. Going to update the Profinet controller so it has all the information it needs. And now I'm going to do the same trick I did earlier again. I'm just gonna download the application, now also with a Profinet stack. And then I'm gonna log out again immediately. Now we download it and we just log out, because now we can again do our network scan, which is really a tremendously helpful feature because it saves you so much time going through the list of all the available devices and manually matching what you have and clicking and clicking. We're just going to add all of them. And now we have the UR20 field bus coupler with our safety IO slice. And you will notice that in brackets here, it has like this little arrow and then another Weimiller one. And this is for our logical IO mapping. So we have our non-safe device tree here. And then we have our safe device tree that like has this logical copy of the UR20 IO. And that's to make, and that allows you to like have full control over the non-safe part of the tree without affecting the safety application and changing CRCs and requiring recertification. So that's quite a nice feature. So now we can start by configuring the non-safe site. So in here you have various options on how like the safety inputs verify their connectedness. And in this case, I'm gonna have these test pulses here set up to be on the aux channels. And I think that's making sure you didn't like crosswire the safety inputs and are reading the wrong one by accident. Yeah, we've done that. So now we can configure the safe side. So here we see there's a screen that has a couple of CRCs on there. This one was produced by a configuration software from Weimiller. I did this ahead of time. But yeah, we can see here now that the CRC for the configuration I put in is this, and it got updated. So now it's not going to complain about misconfiguration when we download. Moving on, we can go to the IO mapping now. And I'm just going to be very creative and call these variables in1, in2, and then I have an output, out1. And that's all the safety IO I have. The rest I left unused. Yeah, now let's add our safety PUUs. And here you actually have two choices. You can do a basic or an extended. Basic only has Boolean logic and you're limited on what you can do. But the benefit is that when it comes to certifying your machine for its safe behavior, you don't need to actually take any looks at the code. You just need to check that for a given set of inputs, the outputs match expectation. So it's simplified certification for the machine builder. Extended gives you more freedom, but now you actually need to go through a code review and all that during certification. So I'm just going to make a basic one. Just going to keep it calling POU. Now we have our network here. And the first thing I'm going to add is a box. And I'm going to use that for my ProfiSafe host to make sure the ProfiSafe connection is running. So I'm going to put that in here. And it will be for the Weimiller 1 device. So I'm going to type that in, automatically maps it as an external variable. And now these top pins here, I'm just going to delete them because I want them to use the default parameters. The only one I'm going to change is the auto acknowledge for errors. I'm going to turn that on. Next, I'm going to add a second network. I'm going to add another box. I'll just say, actually, I'm just going to drag in an add operator from here because that's easier. I'm just going to add in1 and in2 together and then put them out as an output. And that is our very complex safety logic. Yeah, that's all the programming I'm going to be doing for this demo. So now let's set up the communication to the safety control. And that works just the same. It works for any regular CODESYS runtime. So I do a network scan, I see my safety controller, I can connect to it. It's gonna ask me a safety related question, but I'm sure that this is the right instance. And yeah, now I can right click the safety app and log it in. It's gonna ask me more safety questions. And since this is just a demo, I'm just gonna do a temporary debug download to this. That'll go away when I log out. And right click the right thing. And I'm gonna run this application, and we can see here, this is the same online mode you're used from your normal applications. We can see there is no Profi safe communication, which makes sense because we haven't downloaded any of the changes to the regular application side yet. We can see here the error code and the error boolean, and our outputs should be in fail-safe state. Yeah, so let's log in our main application. It will ask me to download, get all the new IO devices I've added in there. It's compiling. Now it's downloading my new application. Oh no, download failed. Let's try that again. Not liking me again. Give my controllers another quick restart. It's always all things. Still working out the last couple hiccups in our safety controller. That's a set, and it's not quite on the market yet, but I think it'll be very cool once it is. Let them down real quick. Put them back up. Download for our safety app again real quick. Start. There we go. That has started. Plug it in, download it, run it, and download our main app. All right, and now we see our Profinet IO came online. Everything is green, so it also got the licenses for network server. And we can see our safety POU is now running. Switch my view here. Now see my buttons as well. We still have the old EtherCAT application, it's just running. And this blue light here with the button is for the safety IO. You can see when I press it, the data updates. And we nicely have everything running together. That's how easy the virtual safe control makes it to run, yeah, safety in a container. It's also very performant. So this example runs at 10 milliseconds. And we've done examples that are like 100 connections and a whole bunch of math, and they still run perfectly fine at 10 milliseconds, and they don't even make the IPC sweat. So this is a really great technology because it's very high performant compared to the rather slow embedded microcontrollers that normal safety controllers have. Yeah, it's really nice. I don't think you could build a safety app that is too big for this technology. Worst case, just get a faster CPU. And with that, go back to my presentation, just to sum everything up. So our virtual safe control SL has the same set of features as the existing control SL runtimes. It uses the same licenses. It doesn't cost any more. It doesn't cost any less, just like any other, but it is highly flexible and scalable, and it works great with modern compute platforms. And then our virtual safe control SL, it can easily run even the largest safety applications you can throw at it. It removes the need for specialized safety controllers and hardware, which tend to be quite expensive. And yeah, it's again highly flexible and scalable, and works great in like a industry 5.0 edge compute environment.